And what is the drawback of that? I think we'll just start with the master slave JK. So basically here we have two JK flip-flops connected back to back. So one is the master and another one is the slave. The output of the master has been connected as an input for the slave. This is how it is. But normally we don't write the flip-flop like that, because here it's not giving any details of what is the input for this master, how it is working, any details of the slave, how it is working. But once we look into the previously discussed one, right? Yeah, wait a minute. I think this would be better. In the last class we discussed with this JK flip-flop, we know the output of these has been connected back as an input for the J and K input. In order to work the JK flip-flops, converting SR into JK, this is the additional input we are going to provide. Similarly, if you are doing it as master slave, we need to follow this same condition now. So how we do that we can't show it here. So that can be shown only if we write the circuit like using this NAND latches. So NAND gates. So we write the circuit like this. You also start writing. So now what we need to write here is two stages of the JK we need to write. So one stage we have 4 NAND gates. So other stage we have another 4 NAND gates. Like this we are going to write the master slave JK flip-flop. So you also start writing along with me. Have provided this SR latch for one for master and one for slave. So the clock input directly triggering the master flip-flop. The negative edge of the clock will be triggering the slave. The feedback from the slave output to the J input of the master. Feedback from the Q output of the slave to the K input of the master. This is how you will connect the master slave JK flip-flop with the NAND gates. So we have written here, so this is only for JK, so that's why we provided this feedback of that there only. But since we are doing it master slave, feedback of the last stage should be given to the first stage now. That's it. So now with this, how does JK flip-flop work we know, right? JK flip-flop 0 0 previous state, 0 1. Yeah, that's what we have written here. 0 0 previous state, 0 1 reset, 1 0 set, 1 1 toggle. Now there is no change in the action of this with respect to the master slave. Only changes is the master will be working. Whatever the working of the master, the slave is copying now. So whatever the working of the master, the slave is copying. So 0 0 0 1 1 0 1 1. We just look into these inputs now. So let me look into this 0 1. Okay. If my input is 0 1 here, I would have written in a different color. Yeah. If my input is 0 and 1, I'll consider some previous stage. Since J is 0, it should be reset, correct? No? I'll just make my Q as 1. Sorry. Q is 1, Q bar is 0. Means when J is 0, K is 1, Q will be 1, Q bar will be 0. Here also we have Q bar, here also we have Q bar. This is the output of the master, this is the output of the slave. For the time being, I've just written both of the same. Later, we'll just check out and we'll verify whether this is working fine or not. Okay. Now, so this is the feedback given, right? And we know one of the input for the NAND gate is 0, means output is 1. So now J is 0, the output of this is 1, correct? So since this output is 1, and what is this output here? I can't decide since K is 1. I need to get this feedback. So this is 1. So 1, 1, I'm only with the application of the clock, okay? 1, 1, 1, all are 1. So output here is 0. So 1, 0 across this. This is your S bar and R bar. Don't forget that, okay? So 1, 0 here means it is reset. So reset means earlier it was 1, now it has been changed to 0. Earlier it was 0, now it's been changed to 1. So it is reset. 0, 1 is the output across the master. And now I need to work with the slave. 0, 1 is the output of the master. So now 0 has been provided for this NAND gate. The output of this NAND gate is 1. So this input is 1 with the negative edge of the clock, 1, 1. So I'll be getting here 0. 1, 0 across this, 1, 0 across this S bar and R bar. So I'll be getting reset, that is 0, 1. So with the input 0, 1, it is reset. I got it 0, 1. Is this clear? Let's look with the reset condition. We just do the changes with the inputs 1, 0. And then we'll look into that. So I'll just retain the present input. That's it, okay? So my inputs are 1, 0 now. I'll just change the input to, reset we checked. We'll just check it with the set. 1, 0 is the input. When any of the input for the NAND gate is 0, the output here is 1. So now for this input, J is 1. So we are feeding back this, right? Here it's 1, right? So 1, 1, 1. So the output here is 0. 0 and 1 for S bar and R bar. The output here is set. So earlier it was 0. Now it's been changed to 1. So now it was 1 before, so it's been changed to 0. It is set. So 1 and 0 is the input now for this NAND gate. So if one of the input for the NAND gate is 0, I'll directly write down this is 1. This is 1. Then for this, it is 1 here and 1 in the negative edge of the clock. So 1, 1, it is 0. So again here I get 0, 1. 0, 1. It is set. So it has been changed to 1 and here it is 0. So this is the output of the JK flip-flop. 1, 0, we get 1, 0 here. So the condition is set. So at any part of the time, you just observe across this slave flip-flop. Either I get the input as 1, 0 or I get the input as 0, 1. There is no condition of 0, 0 at all. We just do one changes with respect to the input of J, okay? So let us take J and K as 0, 0. Then we'll look into this. So what will be the input across this, okay? J is 0, K is 0. What is the output across this NAND gate? If one of the input is 0, we know it is 1, 1, correct? Yes. Yes. 1, 1 across this. S bar and R bar is 1, 1. What is the output? Previous state, right? Because it is S and R is 0, 0. So 1, 1, the previous state. Previous state content, I'll consider my previous state is 1 and 0 suppose. Then it is 1 and 0 only. When this is 1, output is, we just did it, no? If one of the input for the NAND gate is 0, output is 1. So since our previous state is 1, 0, obviously here also 1, 0. So this 0 is being feeded back here, there is no feedback here, 1 here and the negative edge of the clock is 1, 1, 1, output is 0. So we get 0, 1. 0, 1 across this, so it is set 1, 0 only. So previous state was 1, 0. I get the present state also previous state was 1 0. I get the present state also 1 0. As an output across the master is 1 0. The output across the slave is also 1 0. With the 0 0 as an input. Now with the same 0 0 condition across the input, let me consider my previous state is 0 and 1, suppose. Okay, 0 here, this is 1 1. When it is 1 1 previous state, if my previous state output is 0 and 1, if it is 0, what will happen? The output across this will be 1. So then here, since it is 1 and this is 1, this output is 0. 1 and 0. 1 and 0, the meaning is reset. Correct? So earlier was 0 here. Now again it is 0 here. So I consider the previous state as 0 and 1. I get the same thing as 0 and 1. At any part of the time, if you observe across the input of the slave is either 1 0 or 0 1. Means whatever the working of the master, slave will either set or reset irrespective of the J and K inputs. That is very important. One more thing is we'll just work with the J and K 1 1 because this is easy. 0 0 0 1 1 0 conditions are fine enough. Now we need to look into the toggle conditions, how it works. So we'll just do changes here, because we should not get confused with multiple contents here. That's the reason I'm just erasing these. Yeah. So this output I've written 1 0. Fine. I'll write down the previous output is 1 0 only. Okay. With this in output, so what is the working of J and K? J and K is 1 1. So when it is 1 1, I can't decide what is the output of the NAND gates here. The previous stage output here is 1. So 1 1 1. The output here is 0. So previous stage output is 0. 0 1 1. It is, what is this? If any one of the input is 0, it is 1. Okay. 0 1 1, it is 1. All are 1 here, so it is 0. So our S bar and R bar is 1 0 now. When it is 1 0, the flip-flop work like set or reset. 1 in case of S bar is 0 with respect to yes. Okay, it is reset. So earlier content was 1 0. Now with the input J and K 1 1, we get the output 0 1. 0 1 is the input for the second stage of the NAND gates. Now when this is 0, the output across this NAND gate is 1. So here it is 1 and 1, here it is 0. So 1 0 here, reset condition, so I'll get 0 and 1. Okay. So with the J and K 1 1, my previous content was 1 0. Across the master, even across the slave, it was 1 0. Now it's been toggled. 1 has been changed to 0, 0 has been changed to 1. Just because of this change, I can't justify my answer. I need to work out with the same input next time, only then I can justify its toggling. Otherwise, it's working like a reset also. Fine. Again, we'll work with the same J and K input. Now my present output here is 1. 1 has been fed back here. 1, 1, 1. All three are 1. Now this is 0. So here it is 0. 0, 1, 1. Here it is 0. If any one is 0, then it is 1. Correct? So the output across this first NAND gates are 0 and 1. When this is 0 and 1, the flip-flop work like set. So my output is 1 here and 0 here. So it is set now. Now I'll be applying 1 and 0 as the input for the slave flip-flop. When one of the input is 0 here, the output here is 1. So now this is 1 and this is 1. The output here is 0.